Hi everyone, today we're going to be talking about types of data. There are two types of statistical variables. Let's take a look at them below. A categorical or qualitative variable consists of names or labels. The values of this type of variable tends to be given in words rather than numbers. We are placing a piece of data into a category rather than giving it a numerical value. A numerical or quantitative variable consists of measurable quantities. The value of this type of variable is given as a number. To truly be numerical, the numbers must have a mathematical value rather than serving as just a label. Example 1 says, classify each of the following as categorical or qualitative or numerical/quantitative. A says the amount of rainfall in each month of a year in Columbus, Ohio. So again, we have the two options. We either have categorical or numerical, but let's give an example of amount of rainfall. So maybe 1 month is 3 inches. Since that is a numerical value and it is actually measuring something, this is a numerical variable. B says the breeds of 120 purebred dogs. So an example might be German Shepherd, and that is a categorical variable because it is categorizing something. C says the count of books that fall into the horror or romance genre on your bookcase. So maybe you have 5 romance, and that would be numerical because you are quantifying something. Now D is a little bit of a tricky one. D says the zip code of a randomly selected American. So maybe you have 90210. That is in California. It's a zip code, but it is not quantifying anything. It's just serving as a label. So even though it's a number, this is considered a categorical variable. So don't get confused by that one. Now we want to move on to talking about data. When we start observing and collecting values of a variable, these observations are considered to be data. Let's talk about some definitions. Frequency for a category is just the count of the number of items in the dataset that fit in that category. The relative frequency is just the ratio or proportion of the dataset that falls in that category. Relative frequencies are generally calculated as a fraction, written as a decimal, and interpreted using percentages. Except for possible rounding error, the total of the relative frequency column should always be 1. Let's look at example 2. Here are the countries of the top 15 women in the 2019 Boston Marathon. So it asks us to use this data to fill in the frequency and relative frequency of the table below. The first row in the country column says Ethiopia. So what we want to do is up above, we want to count the number of women of the top 15 placed that come from Ethiopia or are representing Ethiopia in the Boston Marathon. So we have 1, 2, 3, and that looks like that's it. So that's going to be 3. Now let's count for Ireland. Looks like there's 1. And now let's count for Kenya. There's 1, 2, 3, 4. And then lastly, we want to count the number of USA. So 1, 2, 3, 4, 5, 6, 7. Now, recall that it said that there are 15 women. So if we counted this correctly, if we add up the frequency column, it should add up to 15. So 3 plus 1 is 4, 4 plus 4 is 8, and 8 plus 7 is 15. So that is a nice check that you can do. So now we want to calculate the relative frequency column. And for Ethiopia, the way we're going to do that is we are going to create a fraction where the numerator is the number of women that are coming from Ethiopia or are representing Ethiopia divided by the total number of women. So that fraction is 3 over 15. And recall in the definition of relative frequency, we write the relative frequency as a decimal. So I'm going to go ahead and pull out my calculator and do 3 divided by 15, and that is 0.2. So 0.2. Okay, so now we want to calculate the relative frequency for Ireland, and that's going to be 1 over 15. So let's do that on our calculator. And I'm going to round it to, let's see, I'll just round it to 2 decimal places. So we have 0.07. And now we want to do Kenya. Kenya is 4 over 15. And that's going to be 0.27. And then USA is 7 out of 15. And that's going to be 0.47. So if we did this correctly, it should add up to 1, but I think because I rounded it to 2 decimal places, it's not going to add up to 1 if we add it like this, but let's just double check. So we have 0.2 plus 0.07 plus 0.27 plus 0.47. So notice that it adds up to 1.01, but that's because I rounded it to 2 decimal places. If I had rounded it probably further out, it would add to 1. So here I'll just put 1 as the relative frequency. And there we go. You have helped me calculate a frequency and relative frequency table. Example 3 says, a group of 12 people are surveyed and asked how many televisions they have in their home. The results of the survey are in the table below. So what this means is each of these numbers represents someone that was surveyed, and that represents their survey response. So for example, this number here represents a person, and they were asked, how many TVs do you have in your home? And that person responded with 2. So there are a total of 12 people that were surveyed. So if we fill out our frequency table correctly, we should get that there are 12 total people there. So let's go ahead and fill this out. So the number of people that responded 0 is 1 person. The number of people that responded 1 TV is 3 people. The number of people that responded 2 TVs is 3 people. 2, 2, and 1. So let's just really quickly add those up. 4, 7, 9, 11, 12. Yes, so they add up correctly. We have correctly calculated our frequency table. Now let's go ahead and do our relative frequency table. So for the people who don't have any TVs, we want to calculate that relative frequency, which is 1 out of 12. So that's 0.083. This time I'm rounding it to 3 decimal places. So, and then we want to calculate 3 out of 12. And that's 0.25. The nice thing is that you don't have to calculate it again for the next one, since that's also 3 out of 12. So you can just rewrite the same decimal. And same thing for the 1 down here. We can just rewrite the same decimal. And then lastly, we want to figure out what 2 out of 12 is. And that's 0.167. So 0.167, 0.167. Okay, so now let's go ahead and add these up to verify that we calculated it correctly. So 0.083 plus 0.25 plus 0.25 plus 0.167 plus 0.167 plus 0.083. And oh, look, it adds up to 1. So there we go. You have helped me calculate another frequency and relative frequency table. And that concludes this section.